Assalamu alaikum. This is Muhammad Mahid Khan Amir, lecturer in mathematics, EMDS, Rajaguttura Model College. Today our class is on general mathematics for class 9 and 10. This is our third class on exponent. In our previous two classes we have learned the formulas and definitions of exponent, and we have done some maths from chapter 4.1. Today we will start. Now our problem is number 19. We have to solve root over 3 to the power x plus 1 is equals to cubic root of 3 to the power 2x minus 1. So to solve this, we have to write the given line first. Then we can see here root over 3 can be replaced with 3 to the power half, as we know from the definition of nth root of a can be written as a to the power 1 by n. So square root of 3 can be written as 3 to the power half whole to the power x plus 1 equals, in the right side it was cubic root of 3, so it will be 3 to the power 1 by 3. So 3 to the power 1 by 3 to the power 2x minus 1, or 3 to the power x plus 1 divided by 2 equals to 3 to the power 2x minus 1 divided by 3. How we got it? We got it from the power law of power, which was like a to the power m to the power n is equals to a to the power mn. So here we have applied that formula, and we got, or applying that formula, we have got 3 to the power x plus 1 by 2, just multiplying x plus 1 with half, and in the right hand side we have got 3 to the power 2x minus 1 divided by 3, and we got it by multiplying 2x minus 1 with 1 by 3. Now we have got two equal thing with the same base, so powers will be equal, or x plus 1 divided by 2 equals to 2x minus 1 divided by 3. Here we can do cross multiplication. From that, 3x plus 3 is equals to 4x minus 2. Now 4x minus 3x equals to 3 plus 2, that is x equals to 5. So the solution of this math is x equals 5. Next math is number 20. Solve 2 to the power x plus 2 to the power 1 minus x is equals to 3. So for solution, we have written the equation exactly. Now we can write 2x is unchanged plus 2 to the power 1 into 2 to the power minus x is equals to 3. This comes from the formula of multiplication, a to the power n into b to the power n is equals to ab to the power n. So powers can be split. That's how we have write it. Now we can write 2 to the power minus x as 1 by 2x. Doing that, we will have 2 to the power x plus 2 by 2 to the power x equals to 3. As we know, a to the power minus n is equals to 1 by 2 to the power n. So applying that formula, we have got this line. Now we have let p equals to 2 to the power x. So replacing 2 to the power x with p, we will have p plus 2 by p is equals to 3. Now doing LCM and cross multiplication, we will have p square plus 2 equals to 3p, or p square minus 3p plus 2 equals to 0, or p square minus 2p minus p plus 2 equals to 0. This line came by middle fact. Now taking common p, we will have p into p minus 2, and for the last two terms we can take minus 1 common, so taking that, minus 1 into p minus 2 equals to 0. Now we got a p minus 2 common, so p minus 2 into p minus 1 is equals to 0. Now we got two factors, both will be equal to 0. Either p minus 2 equals to 0, therefore p will be equal to 2, as we have let p equals to 2 to the power x. So replacing p with 2 to the power x, we will have 2 to the power x equals to 2 to the power 1. As we know, if there is no power, we can give 1 or we can write 1 as power. So 2 to the power x equals to 2 to the power 1. As we have two equal sides have two equal base, then the powers will be also equal. So from there, x equals to 1. And for the second part, or p minus 1 equals to 0, so p equals to 1, or replacing p by 2x, we will have 2 to the power x. And if 1 can be written as something to the power 0, so to solve this math, we have written 2 to the power 0. Now we have two equal things with same base, then their powers must be equal, so x equals to 0. Therefore the solution is x equals to 0 or 1. This was all the maths from this chapter, and next math will be on the CQ 21. Here given, if p is equals to x to the power a, q is equals to x to the power b, and r is equals to x to the power c. We have to find the values of p to the power bc into q to the power minus ca. In number 2, we have to find the values of p by q to the power a plus b into q by r to the power b plus c into r by p to the power c plus a. And in number 3, we have to show that p by q to the power a square plus ab plus b square into q by r to the power b square plus bc plus c square into r by p to the power c square plus ca plus a square is equals to 1. So for number 1, right, we have written p to the power bc into q to the power minus ca. Now replace p with x to the power a and replace q with x to the power b. We will have x to the power a to the power bc into x to the power b to the power minus ca. So now x to the power a to the power b plus c is equals to x to the power a b c by the formula of power law of index, that was a to the power m to the power n equals to a to the power mn. Similarly, applying the formula, we have got x to the power minus abc for the second part. Now we got two terms multiplied, not to be multiplied with the same base. So we can apply the formula a to the power n into a to the power n equals to a to the power m plus n. So applying that, we will have x to the power abc minus abc, that is abc and abc will be cancelled, so x to the power 0, which is equals to 1. So this is 1 is the solution of our number 1. Next math, number 2, p by q to the power a plus b into q by r to the power b plus c into r by p to the power c plus a equals to x. Now replacing p with x to the power a, replacing q with x to the power b, and replacing r with x to the power c, we will have x to the power a divided by x to the power b to the power a plus b, x to the power b divided by x to the power c to the power b plus c into x to the power c divided by x to the power a whole to the power c plus a. In all the three parts, we have division sign with similar base x, so we can apply the formula of a to the power n divided a to the power m divided by a to the power n, which is equals to a to the power m minus n. So applying that, we will have x to the power a minus b to the power a plus b, x to the power b minus c to the power b plus c, x to the power c minus a to the power c plus a. Now we can multiply the powers by applying the formula of powers, a to the power m to the power n equals to a to the power mn. Oh, I have repeated one line, sorry for that. So applying that, we will have x to the power a minus b into a plus b into x to the power b minus c into b plus c into x to the power c minus a into c plus a. Now we can see that we can apply the formula of a plus b into a minus b in all three terms, that is equals to a square minus b square. So x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. That is, now we have got three terms, two multiplication in between them, and all the three terms have the same base x. So we can apply the multiplication law of index, which was a to the power m into a to the power n equals to a to the power m plus n. So doing that, x to the power a square minus b square plus b square minus c square plus c square minus a square, that equals to x to the power 0, cause we can cancel a square by minus a square, minus b square by b square, and minus c square by plus c square. So we will have x to the power 0, that is equals to 1. So our solution of number 2 is also 1. The next math is number 3. Left hand side as it was to show. So left hand side equals to p by q to the power a square plus ab plus b square into q by r to the power b square plus bc plus c square into r by p to the power c square plus ca plus a square. Now we have to replace p by x to the power a, replace q by x to the power c, and replace r by x to the power c. So x to the power a divided by x to the power b whole to the power a square plus ab plus b square into x to the power b divided by x to the power c whole to the power b square plus bc plus c square into x to the power c divided by x to the power a whole to the power c square plus ca plus a square. Now applying the division law of index, we can write x to the power a minus b whole to the power a square plus ab plus b square, x to the power b minus c whole to the power b square plus bc plus c square, and x to the power c minus a whole to the power c square plus ca plus a square. Now we can apply the power of power law of index. So applying that, we will have x to the power, I have again written the line same time, sorry for that, x to the power a minus b to the power a square plus ab plus b square, x to the power b minus c into b square plus bc plus c square, and x to the power c minus a into c square plus ca plus a square. Now we can see we can apply the algebraic formula of a minus b into a square plus ab plus b square, which is equals to a cube minus b cube in all the three parts of this equation, which equals to x to the power a cube minus b cube into x to the power b cube minus c cube into x to the power c cube minus a cube. Now applying the multiplication law of index, as we have similar x as base in all the three parts, x to the power a cube minus b cube plus b cube minus c cube plus c cube minus c cube. Here a cube is can be cancelled by minus a cube, minus b cube can be cancelled by plus b cube, and minus c cube can be cancelled by plus c cube. So we will have x to the power 0, which is equals to 1, and that was our right hand side. Our last math from the chapter 4.1 is number 22. This is also a creative question. The problem is x equals to 2a inverse plus 3b inverse whole inverse y equals to pqth root of x by p, x to the power p divided by x to the power q into qrth root of x to the power q divided by x to the power r into rpth root of x to the power r divided by x to the power p, and z equals to 5 to the power m plus 1 divided by 5 to the power m whole to the power m minus 1 divided by 25 m plus 1 divided by 5 to the power m minus 1 whole to the power m plus 1, where x, p, q, r all are greater than 0. In number 1, we have to find the value of x. In number 2, we have to show that y plus cubic root of 81 is equals to 4. And number 3 is show that y divided z equals to 25. So solution of 1, x equals to 2a inverse plus 3b inverse whole inverse. This was in the chapter also. So we have learned from there a inverse is equals to 1 by a. So 2 into 1 by a plus 3 into 1 by b whole inverse. Here we have applied the formula a to the power minus n equals to 1 by a to the power n. Now multiplying 2 with 1 by a and 3 with 1 by b, we have 2 by a plus 3 by b whole inverse. Now we have to do the addition of fractions there, and for that we need to do the LCM and that kind of things. So adding them, we will have 2b plus 3a divided by ab. Now as we have inverse, we have to write 1 by the fraction, which was according to the formula a to the power minus n is equals to 1 by a to the power n. Now 1 by the fraction is Just the denominator will be on numerator and the numerator will be on denominator. So finally we got AB divided by 3A plus 2B. So this is our answer of number 1. In number 2, y equals to pqth root of xp divided by xq into qth root of xq divided by xr into rpth root of xr divided by xp. In the next line, we have done two things. Firstly, we have applied the formula of a to the power m divided by a to the power n, which was equals to a to the power m minus n. So applying that, we have x to the power p minus k. And to remove the pqth root, we have to add the power 1 by pq. As we knew, or as we know, a to the power nth root of a is equals to a to the power 1 by n. So we have applied these two formulas in all the three parts. So for second part, x to the power q minus r whole to the power 1 by qr, and for the last part, x to the power r minus p whole to the power 1 by rp. Now we need to multiply the powers. As we know, a to the power m to the power n is equals to a m n. So x to the power p minus q divided by pq into x to the power q minus r divided by qr into x to the power r minus p divided by rp. Now we have the three parts with similar base x, and in between them are multiplication signs, so we need to add the powers in the next line. So x to the power p minus q divided by pq plus q minus r divided by qr plus r minus p divided by rp. Now we need to do the LCM and do the calculation. So by doing that, we have PQR as denominator, and in numerator PR minus QR plus PQ minus PR plus QR minus PQ. Here we can see PR is cancelled with minus PR, minus QR is cancelled with plus QR, and plus PQ is cancelled with minus PQ. So in numerator we have left 0. So x to the power 0 by PQR. We know 0 divided something is equals to 0. So x to the power 0 is equals to 1. Now left hand side was y plus cubic root of 81. We have found the value of y is 1 and the cubic root of 81 is 3. So 1 plus 3 is equals to 4, which is our right hand side. So this is the end of our number 2, and now the last part is number 3. The problem is 5 to the power m plus 1 divided by 5 to the power m whole to the power m minus 1 divides 25 to the power m plus 1 divided by 5 to the power m minus 1 into m plus 1. So here we can see in the first part, in denominator, we can apply the formula of a to the power m whole to the power m n equals to amn, and in the second part we can apply the same formula in the denominator also, and in the numerator 25 can be replaced by 5 square as we want the same base 5. So doing that, our next line is 5 to the power m plus 1 divided by 5 to the power m into m minus 1 divides 5 square whole to the power m plus 1 divided by 5 to the power m minus 1 into m plus 1. Now we need to do the calculations, simplifications in the power section. So 5 to the power m plus 1 divided by 5 to the power m square minus m divides, and in numerator of second part, applying the formula which we have used in the previous line. So 5 to the power 2 into m plus 1 divided by 5 to the power m square minus 1. Now in the first part and the second part, both the parts, we have got a division and the same base. So applying the formula of a to the power m divides a to the power n equals to a to the power m minus n. We have 5 to the power m plus 1 minus m square plus m divided by 5 to the power 2m plus 2 minus m square plus 1. Now doing the calculation, simplification, 5 to the power 2m plus 1 minus m square divides 5 to the power 2m plus 3 minus m square. Now again a division sign in between two things. So 5 to the power 2m plus 1 minus m square minus 2m minus 3 plus m square. Now plus 2m will be cancelled with minus 2m, minus m square will be cancelled with plus m square. So we will have 5 to the power minus 2. This can be rewrite as 1 by 5 square, as e to the power minus n is equals to 1 by e to the power n, which equals to 1 by 2 to 25. That's how we get the values of z. Now left hand side was y divided z. we know both the values of y and z. So 1 divides 1 by 25, which is equals to 1 into 25, and finally 25, which was our right hand side. So that's all for this chapter. Hope you understand. Thank you very much, everyone.